Hello everyone and welcome to SUNUP. I'm Lyndall Stout. Each week on our show, we take pride in bringing you research-based information that you can apply directly in your fields. Here's SUNUP's Austin Moore with a new study on planting.
On a blustery morning in a field north of Covington, Elizabeth Miller gathers her team.
Our research out here today is looking at the planting speed effects on how seeds get planted. With our vacuum planter, we have 3 different types of metering devices that are common in the market area. A couple are provided by the dealer, and there's a aftermarket one that we're studying as well. As you're traveling down the field, the terrain and different machine effects and everything affect how and when the seed drops. And we've planted at 4 different speeds. Our speeds range from 3 miles an hour to 9 miles an hour.
This particular study is being conducted in 3 locations across Oklahoma. They do this to broaden the data and ensure that it's not site or soil specific.
Yes, it's all corn in the different locations. This type of study could be applied to different crops, but corn is one of the major crops that they have a lot of different devices to plant with. What our research associates are doing right now is measuring the distances between the plants. Here's a plant spacing that is our typical spacing. We started at the left, and the black marks is where the plants are supposed to land. As we can see, we can kind of get off a little bit, but our data will show how much that is and how that would affect how many plants you're actually getting.
And when all the plants are counted and the data is analyzed, this should provide specific recommendations for producers.
They'll actually be able to take our speeds and look at the different metering systems we used and say, well, what speeds can I travel at with my equipment and my field conditions to make the best decision and maybe what metering device I want to invest in.
So Randy, Elizabeth really showed us how you gather the data in the field, but can you tell us really what's being studied?
Well, we're actually looking at 3 metering systems, 3 different types of metering systems in a John Deere system, a planter at least, and then we're operating those at different ground speeds. Ideally, we were kind of trying to look at how the ground speed influences vibration on the row unit, but the conditions we were in didn't generate a lot of vibration. So basically, we just kind of have the metering systems versus speed. Okay,
so what did you find from that data?
Well, in general, the metering systems kind of performed about like we expected. The standard John Deere plate that has the cells in it for yeah, it has the cells in it for to kind of hold the seed within those cells, and the vacuum pulls them into that. Versus a flat plate where now the seed just sits on top of the hole, and so it doesn't matter what size the seed is anymore. So you can see within these cells you can probably pull a couple seeds into it pretty easily.
Right.
And then the third option. So both of these are from John Deere, and the third option we looked at was the ESET from Precision Planting that has also a flat plate, but that's also a little more complex as far as a doubles eliminator and a seed knockout on it as well.
Okay.
And in general, I would say the trends kind of followed that. Not quite as good, a little better, a little better.
Okay, so just a gradual improvement there.
Yeah, as we saw this, as we kind of changed what we were doing, we'd see less skips and less doubles in the field, and a little better plant spacing as well.
Okay, now then what about the speed you said also was a factor?
Well, speed was a factor we were looking at. We planted 3, 5, 7, and 9 miles an hour. And 9 miles an hour is pretty fast for a planter, but basically we're trying to say, okay, what happens as we spin these discs faster in the planter? And also we're hoping to see a little vibration on the row unit, which indeed we didn't. But in general, planting slower was better.
Okay.
And it kind of depended on the location and some other things. So there's a lot of variability in the data. But up to about sometimes that 7 mile an hour speed would be similar to the 3 and the 5, and sometimes it'd be similar to the 9.
Okay.
And so, in general, where most guys are probably planting in that 5 to 6 range, we're probably pretty good.
Okay.
But if you try to go a little faster, then your plant spacing is not going to be as good.
Okay, so in this case, I guess one thing to take away from this is your behavior in the field has a lot to do with it, more so than the equipment itself.
It certainly does. If you try to drive too fast, then you're going to not get as good a plant spacing as you would if you were driving a little bit slower, probably. But we certainly wouldn't advocate planting at 3 miles an hour. It's just kind of the first time I've done research that we actually planted that slow, because we've never had before. And
Okay.
So I guess
Needed
my
the data.
intention was to say, hey, if I plant at 3, am I going to get a lot better?
Okay.
And the reality was we didn't.
You didn't. Okay. Well, what's next? What's the next stage in the study?
Well, we're going to try to look at this again, and again, we were trying to see, okay, what's the influence of vibration on our seed spacing? So we're probably going to try to be in some no-till environments this year or in 2012, and as we plant corn in the spring, mainly because we're going to see more vibration there as opposed to maybe a strip till or a conventional till environment where the soil's just a little bit softer.
Very good. Well, good information. As always, Randy, thank you for joining us, and we'll be looking forward to the next stage.
You bet. Thank you.